Hello, this is Mr. Mitchell with Physical Science AMI Day 11 for Monday, April 6, 2020. Here's the image of your item for today. I've made some slides to break down each section so we can look at those separately, and it'll be a little easier for us. So here's the informative text. Ozone is a gas made up of 3 oxygen atoms, or O3. It occurs naturally in small trace amounts in the upper atmosphere, the stratosphere. In the troposphere, near the Earth's surface, ozone is created by chemical reactions between air pollutants from vehicle exhaust, gasoline vapors, and other emissions. At ground level, high concentrations of ozone can be toxic to people and plants and is a main ingredient of urban smog. Without ozone, intense UV or ultraviolet radiation would end life on Earth's surface. Ozone is destroyed when it reacts with molecules containing nitrogen, hydrogen, chlorine, or bromine. Some of the molecules that destroy ozone occur naturally, but people have created others. The term ozone depletion means that ozone loss is exceeding ozone creation. In 1956, the British Antarctic Survey set up the Haley Bay Observatory on Antarctica and began ozone measurements using a Dobson spectrophotometer. The graph below depicts recorded ozone over the last 50 years. Instruments on the ground at Haley and high above Antarctica, the Total Ozone Mapping Spectrometer, or TOMS, and Ozone Monitoring Instrument, OMI, measured total atmospheric ozone. The data that has been collected over the last 50 plus years is graphed here. So here's graph 4.4 showing the different observatories with their data sets. So note that Haley's observations are in red, whereas the TOMS observations are in green. And notice that we just have 2 data points from the OMI, which are here. Here's image 4.6. If you notice, darker color means less ozone, whereas lighter color means more. So if we look at these 2 images, we can see that there's more darker areas in 93 than there was in 83. So this indicates less ozone overall in this region. So here's your first question you need to answer. How many stations recorded ozone data in 2006? Well, I would start by asking this question. Where can 2006 data be found? Is it in the text? Is it on graph 4.4? Or is it in image 4.6? Also, we need to consider what increment is used on the x-axis of graph 4.4. And then we're going to want to carefully count the stations that recorded data for 2006. So if I look here through the text, I'm not seeing 2006 here on this page. I'm not seeing 2006 here. If I look here at the graph, I can see on the x-axis, it's showing different decades. And if you look really closely, you can count that increment and you'll see that each line represents 1 year. So recall your question is asking about 2006. How many different stations were collecting data? If I look here at image 4.6, there's no information at all regarding 2006.